In this video, we focus on how can we distinguish between alkanes and alkenes. Now let's look at this table first. Alkanes, the functional groups is carbon-carbon single bond, and the rest of the bonds will be bonded with hydrogen atoms. For alkene family, the functional group is carbon-carbon double bond, and then the rest will be bonded with hydrogen. So that's the functional group for each. For example, if we say propane, prop is three carbon, and 3 carbons are all bonded in single bond, so that's propane. So that's the written example. And then they bonded with hydrogen. It's all bonded with hydrogen. That's propane. Propene still have 3 carbons, but one of between those is a carbon-carbon double bond. Bear in mind, carbon have 4 covalent bonds. So for this one is 1, 2. You have 3 and 4. That's done. For this middle one, 1, 2, 3, 4. For this one, 1, 2, 3, and 4. Right, that's propane. And then you write hydrogen on each bond. So that's propene. Now, next one says, is it hydrocarbon? Now, we know hydrocarbon is a compound that contains hydrogen and carbon atoms only. So that's only hydrogen and carbon atoms. So yes, this is a hydrocarbon. How about alkene? Yes, you don't find any other carbon, any other atoms. So it's only carbon and hydrogen. So that's true. Is it saturated? How do you understand? Saturation means all the carbon bonds are engaged. There is no potential to bond with any other atoms. So for this one, it's carbon-carbon single bond. This all the bondings are engaged. It is saturated hydrocarbon. So that's saturated hydrocarbon. But for this one, because you got carbon-carbon double bond, so one of bond is able to be broken and then bond with another atom. So in this case, this is unsaturated hydrocarbon. Okay, that's the basic concept we have learned so far. How can we use chemical tests to distinguish alkanes and alkenes? If I give you 2 gases, one is ethane, one is ethene, they both colorless, odorless. So how do you know which is which? So this is the trick you need to learn. We need to add bromine water. Now bromine water is a brownish liquid, brownish color liquid. It looks like this. So the bromine water looks like that. So if you have 2 test tubes of gases, one is ethane, one is ethene. Now you don't know which is which. Of course, you have a lid on the top to stop the gas escape. Then when you add bromine water to it, and then you quickly shake, then one will be decolorized. The other one won't. So you will know which one is alkane, which one is alkene. Now the one has been decolorized is alkene family, belongs to alkene family. Now the other one don't react, still remains orange color, that will be alkane family. That's how you know it. Let's look at the chemical reaction. Now chemical reaction is like this. For instance, ethene. Ethene, you have a carbon-carbon double bond. So as I said, one of the bondings is easy to be broken. So when that react with bromine water, bromine is Br2. When that react together, the double bond will be broken, and then the bond is able to bond 2 bromine atoms. So it becoming 1,2-dibromoethane. You see, ethane means carbon-carbon single bond. 1 and 2 is a position where bromine atoms are bonded, and they bonded what atom? That's called bromine, so that's bromo. So 1, 2, di means 2 of those, dibromoethane. And this chemical is a colorless chemical, and therefore this ethane is able to decolorize the bromine water, so this water's color disappeared. So that's how you tell. But with regard to ethane, because it's carbon-carbon single bond, then it will not be able to react with bromine water because it's a saturated hydrocarbon. So there is no reaction. Yeah, that's how you tell. And if you look at propane again, we're still concentrating on carbon-carbon double bond because this too is saturated, it won't react. So if you add bromine water to propane, the same results appears. Carbon-carbon double bond is broken, and then you will be bonded with bromine atoms. So those 2 bromine atoms goes to here. So that will be, again, bromine water is decolorized. So you need to be careful how you describe it. So please do not say the final mixture is clear. If you say that, it may not give you the mark. You need to say the bromine water is decolorized. That is the best way and the safest way to say. Or you say the mixture is colorless. Yeah, please do not say it is clear. And that is not accurate. Okay, so here we say, if you look at here, they are using the word decolorized. It's somewhere here, I found it for you. See, a compound with carbon-carbon double bond will react with bromine in a similar way with ethane. This is used to test for carbon-carbon double bond. So if you shake the unknown organic compound with bromine water, the orange bromine water is decolorized. See, use these words. It's the best way to describe. Okay, that's how you distinguish between alkanes and alkenes.